Okay, so this is my work for question number 2 on 2015. So the question originally asks, I have some givens written down here, but I'll read the question. At time t is greater than or equal to 0, a particle moving along a curve in the xy plane has position xt, yt with velocity vector vt equals cosine t squared e to the 0.5 t at t equals 1, the particle is at 0.3, 5. So for A, you're supposed to find the x-coordinate of the position of the particle at time t equals 2. So one thing to remember is that the x and y components can be independent. So from that, you know that you're supposed to find the position at t equals 2, so you're going to use your integral. But when you go originally down to this, you realize that you have your 2 and you have your cosine t squared dt, but you don't have this point that I will later I'm going to show why you put 1 there. So you have your position at t equals 2, correct, and you find your integral for that. But you know that your initial coordinate that you were given in the original problem is 3, 5, and then at t equals 1. So with that, you can use this initial coordinates, initial position, to plug that in here. And you're going to use the 3 as your x value, and you're going to add it to this integral. And then you're also going to put the t equals 1 as your as the starting point of your integral. So it's going to be from 1 to 2, and that's why you're going to add on the 3. So once you plug this all, once you have this all in your equation, you can put in your calculator, use the integral, plug in from 1 to 2, and then cosine x squared dx, which you should get negative 0.443. Then what you're going to do is you're going to add that initial x coordinate or x value of 3. So you're going to have 0.443 plus 3, which equals 2.557. Okay, so the next part B is asking you for 0 is less than t and t is less than 1. There's a point on the curve at which the line tangent to the curve has a slope of 2. At what time is the object at that point? So before we get started, just a reminder that the slope of a parametric curve is dy over dx is equal to dy over dt over dx over dt. So to keep that in mind as we're going. So we are given our slope, the slope at 2. So, and we're also given t. So what we're going to do is we're going to use that slope of the parametric curve, and we're going to set it equal to 2 because we know that obviously the answer is going to be 2. So we have dy over dt over dx over dt. The dt's cancel, and then you have 2 equals dy dx. Luckily, we are already given the velocity vector, which is already our derivative point. So you have your xt and you have your yt's derivative because the velocity vector is given. So what you're going to do is you're going to take your 2 and you're going to set it equal to your dy over dx. So your dy was e to the 0.5 t, and then your dx was cosine t squared. So you're going to put that in, just plug that right in. So 2 equals e to the 0.5 t over cosine t squared. And you're going to take this and you're going to plug it into your calculator. But what you're going to do is you're going to find the graph and find the intersection. So you're going to do y1 is equal to e to the 0.5 t over cosine t squared, and then you're going to have your y2 as 2, and then you're going to hit graph. Once you hit graph, you want to make sure your window is set to x equals 0 and to x equals 1, and then you're going to find the intersection between those two things that you've graphed. So you're going to do your intersection, you're going to do your first curve, second curve, and then you know that your slope is equal to 2 at t equals 0.840 because that is where the two things that you've put in your calculator have intersected. So your answer is t equals 0.840.